We have left off in the topic of options. We are inside exercises, options 1. And as you can see, I've already opened it. So before I start with the exercise, I want to briefly show what is the meaning of option and why do we actually need it. So I will here just basically write some stuff so you can see. Now, if you're coming from another language, you will basically know null. Null just shows the absence of a value. So, for example, we are iterating over something and we exceed the index, then for example we get a null value. Or for example with JavaScript we are making a request to a server and the server did not respond and we are packing that in a value, it will basically be null or sometimes undefined. Now in Rust there is no null. You won't find it anywhere in the language because Rust has an alternative which is called option. Now option is actually an enum, and in the standard library it's like that. So let me see. In the standard library you will have an enum. I can show you that really quick. Public enum option T, and you have none and you have some. So let's actually do it like it's in the example. You have a public enum option which takes a type, and this is a generic. We will go into that later. But you basically can replace this T with any type. So you can pass option any type and it will either return none or it will return some. And if it returns some, it will be in this sum will be the actual value that is passed to the option. And why it's like that? Because Rust is type safe and memory safe. So basically, if there is none, if there is no value, Rust makes you that you actually handle this in case of an error. So you have to handle everything yourself. And you will see what I mean when we do the exercises. And I'll go outside that and we can start. This function returns how much ice cream there is left in the fridge. If it's before 10 p.m., there is 5 pieces left. At 10 p.m., someone eats them all, so there will be no more left. To do return an option, so as you can see we have a function here, maybe ice cream. It expects an argument time of day which will be unsigned integer, and it returns an option which has type unsigned integer. So we use the 24-hour system here, so 10 p.m. is a value of 22. The option output should gracefully handle cases where time of day larger than 24. So we have to implement this function, and I will take a brief look over that test. So as you can see, we are exporting, and this is actually the syntax for it it imports anything in the super modules. So anything that is written over here will get imported. which in this case is only one function, but so you will know what that means. And then here we have a test function, check ice cream, and it calls this function with unsigned integer types. So here we have maybe ice cream 9, and then it should return 5, because 9 is before 10 p.m. or 22. 10 will return 5. Now 23 will return 0, because it's after 10 p.m. And 10 p.m. itself should also return 0. And of course, if we pass it a value above 24, it should return none. And this is basically in other languages null. So it has the same meaning. And then over here, raw value, fix this test. How do you get the value contained in the option? All right, and here again, we are calling the function maybe ice cream with 12, and we want to store that in a variable, and then it should have here the assertion equal. This should be equal, but it is not in the moment, because this will return sum 5. And we want this variable to hold only 5. But let's do that in the end. So we will start over here. So basically what we have to do is just checking, and I will use a simple if-else blocks. So if time of day is larger than 24, we will simply return none, like that. And over here we have to explicitly return it, because we want the program to exit in case of none. If this time of day is past a value above 24 hours, because there is only 24 hours, we will immediately exit. So that's why we explicitly type here return. So return none, it will immediately stop executing and return a value of none, as you can see here. And then we will have another condition, time of day, and if time of day is less than 22, we will return sum 5. So as you can see here, if it's before 10 p.m. there is 5 pieces left. At 10 p.m. someone eats them all, so there will be no more left. So if it's before 10 p.m. or 22, there will be 5 ice creams left, and else there won't be any left, like that. And of course, because here it's the end of the program, we don't have to type here return. It's implicit, like that. So if time of date is less than 10 p.m., we have sum 5, else sum 0. And as you can see, this is the return type. So we return either none, either sum 5, and either sum 0, like it's over here. Yeah. All right. then over here to do fix this test, how can you get the value contained in the option? So actually here the simplest way, because as I've said, we have here sum, or we have here option unsigned integer 16 bits, like that. But we actually want the value out of here. We don't want an option to be returned, we want a value. As you can see, option unsigned integer 16, and we don't want that to be returned here. We want basically just the value. And when we pass 12, the result will be sum 5, because that's what we implemented. This will be a function call with the argument of 12. We will go over here, then it will check if time of day is larger than that, which 12 is not larger than 24, so we will go over here. If time of day is less than 22, it will return that, and in this case 12 is less than 22, so we have sum 5. This will be the return value. But we don't want this return value. We want to basically just take the 5 out of this sum. And the simplest way to accomplish that is just to call unwrap. And what unwrap does is just, it will take, if the functions return sum and the value, it will just basically unpack the value and return 5. And if it's none, so if none is returned, it will just stop executing, so it will panic. So if this would return none, we will have a panic. Panic basically means it just stops, the whole program stops executing. So if we call unwrap over here, we will get a return type of U16, like that. And then we can basically just here assert that these two are equal. So let's see. As you can see, it's passing. Now there is actually another way, and it's called expect, and it's actually the same as unwrap, but you can pass it a message. So should return 5. And expect also, it takes the value out of this sum and it returns just the value, like that. Like that. So sum 5 will return 5 when we call expect on it. If it returns none, then it will panic and it will just print out this should return 5 in the output of the compiler. So let's see. This also will return U16. And as you can see, it's also passing. Now there is another way, and if you want to be really fancy, you can do it like that. So you can basically unpack it with if let statement. So you pass here if let, or let me just delete anything here so we will start clean. If let some, and then we have ice creams. Then over here we basically just pass it this this one, so like that, and it should also do the same thing, as you can see. So if let actually takes here this function call, and the return type will be option u16, which will in turn return sum and 5, and we then basically just take the 5 and put it in this variable. So ice creams will be equal to 5, and then it will get asserted like that. So if let some ice creams, and then we can use this as a normal variable. This will hold 5 like that, as you can see, and everything has been compiling. Let's check it again. All right, 3, and we are in options 2. So over here we only have tests basically this time. We have a function, simple option, we have a target, this is of type, can you guess it? It is a string slice, like that. Then we have here optional target, and the type of this is option and string slice, because sum is actually in the option enum, and it will get passed a string slice. As you can see here, this will get passed. And then to make this an if let statement whose value is some type. So basically what we did right before, we make here if let some, and we just pass it like that. So optional target will have this type, and then what this will do is just it extracts out this sum, and basically we then have this variable word which we then can use. So word will then hold a string slice value. And then all we do is basically compare this word which holds the string slice value over here and the target. So here basically what we will get is Rustlings equals Rustlings, like that, which will be true, so the test should pass. Now over here, layered option. So we have a range of 10, and we have optional integers. And this is a vector which holds options of type integers. So basically, I will show you that in a moment. We have here a for loop for I in 0 to range, and range is 10 plus 1. So this will iterate from 0 to 10, because here we have range 10 plus 1 is 11, but here this won't be included, so 11 won't be included, so 0 to 10. And then I will hold 0 in the second iteration, 1, 2, 3, and so on. And then optional integers, that's over a vector, push, and then we push option values. So here some 0, some 1, some 2, like that. And basically the vector will then look something like that. So we have some 0, some 1, some 2, like that, until some 10. So we have, as you can see here, a vector of option I8 values. So each option will hold an integer like that. And then to make this a while let statement, remember that vector.pop also adds another layer of option t. You can stack option t's into while let and if let. So what this is basically saying, I will show you that in the Rust homepage, in the documentation. So we have here in vector a method called pop, which takes a mutable reference of self and it will return option t. So removes the last element from a vector and returns it or none if it is empty. If you'd like to pop the first element, consider, okay, that's not important here. So we have a vector here of integer types 1, 2, 3, and then what we do is vec pop. And here, as you can see, when we call vec pop, it will return this integer wrapped in a sum, which is of type option t, so sum 3. And then it will, the vector will have these two values because the third one has been popped. So this itself, this function or this method will return option. So you have basically over here nested options. So when we call pop, for example, and we have here this vector with these option values, 1, 2, like that, and then we will, actually let me do it like that so you can see, then we will call pop. And what this does, it basically returns sum and then sum 10. We have here nested values because, as you can see, here we have 1, 2, 3, we pop and it returns sum 3. Now in this vector, the elements are already in sum. So if we pop that, we return sum 10 wrapped in a sum, which is basically option value. So we can also write it like that. So this actually will return option, and then inside that we have another option, and then inside that we have I8, like that. This will be the return type, or this will be the type this variable will hold. So here we can write while let, and if it returns sum, and let me delete that one. If it returns sum, we will take this value integer, and here, as you can see, we're just comparing it to the range, which has just basically holds I8 values, let's say. And then it will basically decrement range by 1. We are in a loop, don't forget that. So in each iteration, range will be decremented by 1. So we will start with 10. And we pop here the last value, which will be sum 10. Then we will get 10 in the integer variable, and we compare 10 with range, which is 10 in the beginning. So 10 equals 10, this should return true, and then range will be decremented by 1, so we have 9. And then again, same thing, optional integers, this vector will get popped, so the popped value will be sum 9. We will unwrap this like that. We have here 9 in the variable integer, and then we have 9 equals 9, and so on and so forth. So let's see if it's compiling, and it's not compiling. Mismatch types, expected enum, option found I8. And of course, we have here a nested option type. As you can see, now it's compiling. Of course, we had to make two sums because it will actually return sum, and integer. As I've written before, this will return option, and then option, and then I8, like that. So to destructure it, we have to call sum, integer, like that. Because, as you remember, we have a vector of type sum 0, sum 1, and so on. So this will be to get the value inside here, and this will be to actually get to the elements in the vector, because as you've seen, pop itself will return a sum value. So we have to use the first sum to actually get to the element, for example sum 0, and then again sum and integer will then hold the actual value, like that. Let's see. And it's compiling. All right. And we are in the last one. So we have a struct point with two members. X is an integer, y is an integer, and in the main function we have a variable of type option point. And here, as you can see, we pass it sum. So this is wrapped in a sum, and we initiate it with point x100, y200. So this variable will hold this value, which is of type option and point. Now then we match y, and here basically we try to get the value out of the sum. We want to use that one, and then we print just these two values over here. So p, which is of type point, dot x will return 100, and p dot y will return 200. And we just print that out. And now in a match you always have to handle the case where there is no match. So if there is no match, we have print line no match. And then we will basically just want to use y again, and that is actually the problem, because here you can see value partially moved here. So the value p actually gets moved, value used here after partial move. So, and I want to show you that in the documentation. So as you can see here, by default match statements consume all they can, which can sometimes be a problem when you don't really need the value to be moved and owned. So when we have a match statement over here, and we match, for example, sum n, and then it will print out hello Alice, because n in here will actually match this, will print out n, and n in this case is the value inside this sum, which is string from Alice. So it will print out hello Alice. If this option will return none, it will print hello world. But we can't then use maybe name, that one, again, because maybe name, this variable, will be consumed. So this match case actually takes ownership over this variable, and we can't then use it again. And in this case, we can, using the ref keyword, the value is only borrowed, not moved, making it available for use after the match statement. So here we have basically the same thing. We have a string Alice wrapped in sum, which is of type option string. And then we match this variable, maybe name, and we want to access the value inside sum. And here, as you can see, we just add ref. And what this does is basically the value of maybe name, this one, won't get moved inside here. It's just passed as a reference. And we print then hello Alice. If there is no match, we will print hello world. And then we can actually use it again. So as you can see, hello again, and then we call maybe name and unwrap the value inside the sum statement and then world. So this will print out hello again Alice, and we can actually run that so you can see it. Let me run this, and as you can see, hello Alice, because here we print hello Alice and then hello again Alice. As you can see here, hello again Alice. So we can, even here after this match statement, we can access this variable without any problem. And here I think this is very important, so I will read it for you. The ampersand denotes that your pattern expects a reference to an object. Hence, ampersand is a part of said pattern. Ampersand foo matches different objects than foo does. Ref indicates that you want a reference to an unpacked value. It is not matched against foo, ref, foo. Matches the same objects as foo, foo. So what this basically says is, if you have here an ampersand instead of ref, you are looking for a reference. You're matching a reference, so this won't pass, and you will print this one because here this is not a reference. This is an owned value. String is an owned value here, so this will not pass. But here we are typing ref because all we want is to just the value over here, it does not get moved inside this match statement, it just gets passed by reference. That's all to it. So all we really have to do is just pass here ref, and it should compile. As you can see, coordinates are 100, 200. Like that. And just to show you, if we pass here ampersand, as you can see here, expected struct point found reference. So this is actually an owned value and not a reference. So this will actually match references, but this, in this case, P, for example, is not a reference, is an owned value. So that's the difference. So ref basically just says we want these types, the value P, which is point here. We don't want this value to be moved inside over here. We just want a reference to print it out, and then we can use Y without any problem. Like that. So, and I also recommend you to just go over the book. So, because in the book you have a lot of details, option might seem a little bit confusing in the first tries, but you will get the logic if you have it. So let me see here, where has it been? Defining an E now. Let me search for it. Yeah, it's basically in the error handling. Like that here with result. And also down here you will find option, and it's over here. here you have E flat, and you see some, so it basically here explains all about options. So I highly recommend you to read about it, because as you can see, it was a little bit confusing. I tried my best to explain it to you, but maybe you will want to take a look into it. And our next topic will be error handling, and see you by then.